Algebra 2, Conic Function, Characteristics and Equation. The conic function in high school you probably learn in geometry. Here we use analytic method. What's analytic method? Analytic method means you use xy coordinate and describe the shape by the function. Okay, so by the equation. So conic, if you probably learn, suppose you have a cone 3D shape. When you slice this, you slice this way, this cross section will be circle. You slice tilted, this cross section will be ellipses. If you slice this way, this cross section will be hyperbola, right? So its conic is bundled into single group as a same family of function. The reason is it's come from the single type of equation. This is general form. General form is ax squared plus by squared plus cxy plus d plus e plus f equals 0. So this represents all the different shapes, depends on the coefficient a, b, c, d, e, f. Okay, and in this equation, ellipses could be tilted like that, not necessarily horizontal or vertical, and the center is not necessarily the origin of xy coordinate. Okay, so this is a very general form, and depend on the coefficient, it become hyperbola or circle. So this quadratic function, basically it's a quadratic function. The x and y both are suppose you coefficient b is 0 and c is 0, then you have y, you can make it y equals, if you make this form, you know it's a quadratic function, right? So quadratic function is a very special case of conic function. And the inverse function of conic function is also conic function, because look, x, y can be symmetric in the role of the variable. Okay, so once you eliminate cxy term, then it can be changed to this. Means this going to be, if negative, hyperbola, if positive, ellipses, if a equals b, then it's a circle, right? So the question is, when cxy becomes 0, the cxy is a contributor to tilt ellipses shape. The cxy, if you change coordinate into this is xy, and introduce new coordinate, and using x prime and y prime, the equation, you see this term c becomes 0. Okay, and basically we do coordinate transformation. This is coordinate transformation, means we move the coordinate by certain angle, then it's become horizontal or vertical, and once it's become horizontal or vertical, then on new coordinate x prime and y prime become simpler equation for ellipses. Circle is a special case of ellipses or hyperbola. Okay, so this cxy term is a complication. The orientation of the function change, and well, we can get into the detail of this, the coordinate transformation. What we do is coordinate transformation xy into new coordinate, and this coordinate transformation matrix, we use this equation. Basically, x prime is going to be some x and y equation, and you plug in y prime is something x something y, and you plug in this. Well, we do other way around. X and y is going to be using a new coordinate. You plug in this equation to this general form, then clean up, c becomes 0. Okay, that's the proof. We can go through, but it's get very long. It's not much learning value, but however, you can do it by yourself and prove that c becomes 0 by proper coordinate transformation, and that's going to be very challenging task for you, but you need to do only once, so you understand what this means. So the simplest form is when a and b's are same, then it's becomes circle, and x1 and y1 here is going to be the coordinate for center point. X1, y1 here. So since a equal b, you multiply both on the both sides of equation, and this is going to be the typical simple circle equation. Okay, so x square and y square and a square. A is radius, and you can prove that simply. You can check it out. So you can verify y radius is a here. Say this is x, right, and y, and center is x1, y1. This is the distance, and distance square and distance square, Pythagorean theorem, right? Then this is a square, so that must be a must be the radius. Okay, so ellipses, a is not equal to b. So when a is not equal to b, then suppose this ellipse is sitting right in the middle of the coordinate xy. So we need to define kind of two split center, which is c and negative c on x-axis. Okay, so the coordinates are shifted to simplify the function form. Coordinates are shifted. So when you move ellipses, and change the coordinate to this, that means y equals y1 and x equals x prime minus x1, then this changed to this simple form. And there are many theory about the distance from C and negative C, and also, you know, this ellipsis was studied very much by Kepler and Newton, because basically the planet movement is ellipses, and usually the center planet, the sun, is at the C point, and this ellipsis is gradually moving like that. So it's a planet movement. Because of that, there are many theories about this C minus in C point, and the sweeping area by planet movement and the lengths. This is called focus point. Many things were studied by Kepler and Newton's in order to apply that to the planet motion. Okay. Now, when this sign is negative, so what's happened? It becomes a hyperbola. Hyperbola function is like this. Then focus point is going to be outside. And why this become a focus point? Because this curve is very peculiar for the light refraction. When parallel lights come in, reflected lights go to the focus point, because you know the light refraction law, Snell's law in the physics. This equal to this, right? This is the surface, and this is the perpendicular to the surface, and the angle to the perpendicular line is going to be equal for the incoming and outgoing light. Applying this law, the lights coming in is gonna concentrate on this focus point. On the other hand, if you have a light bulb here, then all the lights go out by reflector by hyperbola as a parallel line. So in order to create a searchlight, the searchlight depends on shape. It may spread, then it's cover a wide area, but it doesn't go far enough. If you make a shape a little bit too curvy, then the light cross here and spread again. That's not good either. Ideal, the light reflector is to emit the light parallel, so it's go far enough to spot the object in the distance, right? So what is a curve to make it this parallel light from the source of the light, which is hyperbola? Okay, and again you move the equation to the center. Say you have a hyperbola like that, and this center coordinate is x1, y1. They convert the coordinate using x coordinate, new coordinate is x prime minus x1, so and so. Then it's become a simple equation like this. Okay, so it's got a two focus point on each side. So that's the conic function, hyperbola. Now some exercise here. Find the coordinate C1 and C2 to center the conic function in the new coordinate. Okay, how you move this into the center here. So new coordinate x is previous coordinate x plus C1, and the capital Y is Y plus C2, and you plug into this general form, right? And you want to make a D1, E1, 0. So we both coefficient 0 to eliminate x and y term. In order to do that, the coordinate C1, C2 must be this value. If coordinate C1, C2 are this value, then the new coordinate is going to be used to have a something centered here. Okay, so what you do is you move this first, then later you eliminate cxy here, cxy. How do you eliminate cxy? The another coordinate, this time it's not a parallel movement, but it's a rotation, and use the rotation of coordinate, plug in and set the c equals 0. That's gonna be the equation. So the new coordinate, it's going to be ellipses become horizontal or vertical on the new coordinate, the rotational function. This is assignment for you. Conic function ellipses. 4C point as a equal a to a squared equals b squared plus c squared. The sum of the distance d1 d2 is constant to a. Okay. Well, I think you should stop the video and prepare pencil and paper and do this practice. Okay. The objective is to set 4C. There are two focus points. This 4C, 4C point, a square equals b square plus c square. Okay. This is the b. This is a square. The relationship is a square equals b square plus c square. So you take the 4C by this relationship, then the distance d1, this distance, and d2 is constant to a. Okay. Okay, so this is your assignment, and we move on this video. Now, hyperbola, we prove setting a 4C point the same way, but a plus b square plus b square equals c square. In this case, a is this point, b is certain point here, and c is the focus point. The difference between d1 d2, this time is d1 d2, is constant. Okay. So here's another exercise for the 4C of hyperbola. Now, next one, this is to give you, I said in the beginning, this coordinate can be transformed by angle, and this is the transformation equation. If you want to move theta, it's going to be cos theta minus sine theta. Matrix, you remember the matrix, it's going to be this multiplied by this plus this multiplied by this. So basically a trigonometry, other way around, some trigonometry. Okay, so you plug in this one to the equation, general form of equation, then you try to find the theta to make this guy 0. C is 0. In order to make this 0, what is the theta? And once you determine the theta, then you use a new coordinate. Then equation become like this. Okay? Okay, so a lot of equation and a lot of things to prove in conic function. But this is an exercise you go through once, and tell you a lot of Asian university, the college entrance exam give you those questions. The prove certain characteristic of 4C whatever on a conic function stuff. You have to go through this to get into the college. But fortunately here in the state, they don't go that extent of difficult questions. The SAT 2 is very limited. You hardly see any question about conic function. So, but in the college, you got know this. If you are in science, engineer, and the math major, definitely you have to go through this. So spend some time and completely understand what it means about the converting coordinate, moving that to parallel position and rotating it. This is a rotating general form. Every time you rotate the coordinate, it's become this conversion equation. Okay, so the just analytical geometry require equation to find out the property or characteristic of the geometry, like ellipses, circle, and stuff. Okay, so it's not geometry, but this is a part of algebra too. Okay, I hope you enjoy listening this video, and we'll see you in the next video.